Okay, so here we have a few the questions we had in the exam. Okay. The first question is just a limit question. What could you do in that question? How would you simplify, evaluate this limit? Simply substitute the 2. Okay. I don't have to simplify the fraction because I don't have a denominator that will be 0. So I simply substitute the 2. So I get 3 times 2 is 6, plus 6 is 12, divided by 2 is 6. Guys, I'm sorry. Okay. So everyone okay with that? Evaluating a limit is simply substituting, unless I can't, then I first simplify. So this was typically a knowledge question. Actually, it's a question that really takes no effort to do. It doesn't take understanding. It takes all it takes is knowing what limit means. Okay, this one. How would we answer this question? What is this question asking us for? It's just asking for the first derivative. How do I answer? Do I just answer with an expression? Do I need to simplify the inside? No, it's in a simple form. Each x has its own exponent. It's not divided by anything. Okay, so this answer is just multiplying the 2 in front. 4x, the derivative of a constant is 0. So this is simply the answer. But must I still keep the dx in? No. If I do that, I'm asking to get the derivative of the inside. The answer of this thing is that I have found the derivative. That is 4x. Okay, here's a good example of what we just did a little while ago. An object is thrown up into the air and its height above the ground in meters is given by the following expression. How high is the object after 2 seconds? So we simply substitute, because we have a formula for height. So we simply substitute 2 in there, and I get 24 times 2 is 48. 48 minus, this is 4 times 4.9, 19.6. Okay, so 48 minus 19.6, 28,4 meters. Very important to use units when they're talking about specifics. The height after 3 seconds is the same as the height after 2 seconds. That's actually not true. That was an error in the question. That doesn't really matter. Explain how this is possible. How is it possible that you throw something up in the air and after 2 seconds it has this height, and after 3 seconds it has the same height? Just stand still there for a minute.
Is that possible?
Yeah.
Oh, say for example, maybe after 2 seconds exactly, it went a bit further, and then 2.5 it was higher, and then 30 seconds it came back to the same.
Exactly. Yeah. Exactly. So in other words, at 2 seconds its direction or its height above the ground was 28 meters as it was going up. Then between 2 and 3 seconds it turned around, and now it's heading down and reaching the same height. Okay, it's a parabola, look there. It's a parabola. And at 2 seconds, apparently there's it at 3 seconds, it has the same height. So again, it wasn't true. There's some, I don't know how I got that wrong. But the idea remained the same. You didn't have to go and calculate it. Okay, find an expression for the velocity of the object in terms of t. Okay, so height is displacement. Okay, it's just horizontal, vertical displacement. So how would you find the velocity? You just find the derivative of the height formula is equal to 24 minus 9,8t. What is the initial speed or velocity that the object was thrown upwards with? Sorry? 24. Why 24?
Why 24? You take the derivative of the distance
and there's it is. So this is the velocity formula, okay?
Yes. But when you threw it out, the t was 0.
Good. Initial means there's no time has passed yet. So initial t is 0. So if t is 0, v of 0 is 24. So if you put a 0 in there, you just get 24 again meters per second. The second derivative is equal to negative 9.8. Explain what this means in the context of this question. Okay? So the first derivative is velocity. The second derivative would be acceleration. So we know acceleration is negative 9.8 meters per second squared, or meters per second. So what that means is every second I'm losing 9,8 meters per second. I'm losing velocity because it's negative. It's a second derivative, which means my derivative is changing. So if it's negative, my derivative is changing, it's decreasing. So, and my derivative was velocity. So now putting all of that together, if my second derivative is negative, it means my first derivative, velocity, is losing negative, or losing 9.8, and since I'm working with velocity, meters per second, every second. Okay. So if I started with 24 meters per second, after 1 second, I would have had lost 9.8 meters per second. So then it would be 15,2 meters per second. Okay, after the next second, I would have lost again another, so then it would be 6,4 meters per second. So this is after 2 seconds, I'm going. After 3 seconds, I'm already heading down again. You see, because if I lose another 9.8, I would be at 6.4 minus 9.8 is 5.6. Is it? 5.4. Negative 5.4 meters per second. Okay? Do you see? Can you see here that somewhere in between here it turned around? Somewhere between 2 seconds and 3 seconds.
So I think this. Are you losing from 24?
No, you're losing. Yes, you started with 24, then you lost 9.8.
So it's 14.
Is it 14.2? Oh, I'm sorry. 14.2, then this is 4.6. 4.4. Oh, sorry. And then this is minus 9.8, 5.4. Is it? Minus 9. What is it then? 4.4 minus 5.4? Sorry, 4.4 minus 9.8?
It's negative 5.4.
Okay.
You're right.
That's weird. Okay, cool. You guys get the idea what we mean by what is happening? What does it mean? What is that in the context of this scenario? Then you look at, now you got 1 poor mark if you mentioned acceleration, but no one understood acceleration by explaining scenario. Acceleration means losing or changing your velocity with that amount every second. Okay, now here comes the difficult question, and I think of all the students, only one got it right. Okay, so here in this question, they tell us, what did they give us? In other words, what did they give us? They gave me the derivative, they gave me the gradient. This is a gradient, and they asked me to find the equation of the original. So if this is the gradient, what is the standard form of the original? Ax cubed bx squared plus d. Now what is, so they gave me the derivative. I know that the original must then be that. Why do you say this is the original? Why isn't it a straight line or a hyperbola or what? Why do you say it's a cubic expression?
Because the gradient from the derivative is
A parabola. In other words, you know, if I find this thing's derivative, what do I get? 3ax squared plus 2bx plus c. Shoot me. What can we do next? You could, okay, well, let's do that. Oh, you mean this one?
Yeah.
Second derivative is, okay, well, maybe that can also help. And then what do you do with that?
When we supposed to, before that derivative, when we supposed to substitute the point?
What point?
10 for the point.
Where, okay, so where would you substitute this turning point? In here.
Yeah.
Okay, so you're saying we have -2, no, you've got your -1/3 is equal to 3ax is -2/3. Are the rest of you just waiting till someone else says something? 2/3. Are you trying something, Tukuzwa? What did you try? Huh? Just tell me what you tried.
I'm just trying to know the formula, but I came
What formula? The gradient formula. This formula. M.
Yeah. Y then we just substituted, so it's 1, 2 minus 1 equals to n.
No, we only use that with straight lines.
Yeah, that's why I said that didn't
Okay. Do you guys think you can find the equation for this thing? Forget about anything on this side. Would you be able to find this thing's equation? Just with the information in the graph. How?
By that formula, first it's a and then x minus x1. Yeah, bracket x1.
Mm-hmm.
And then
Oh, so I use R1 and R2, okay, just to indicate roots. No, that's fine. I don't mind if you use X1, it doesn't make a difference. Okay.
And then now we substitute. Now we can substitute the points, I think, the X point.
What do you substitute where? Paulina, you seem to have an idea.
Let's say we want Y, we let the X.
Guys, this is simple. It's
If
if this, yeah,
substitute x, you say x, write x plus 1.
X plus 1, you substituted the negative 1 into R.
Yes.
X
Yes.
plus a third.
Is it not minus it there?
No, that's a, you can't see it there. Can you? There's a negative in front there.
Oh, okay.
Sorry, yeah, there's a negative in front there. So minus plus a third is equal to that. Okay. And then A is still unknown. We still need to find our A. But it's my last parameter left to solve. So how do I find it? Substitute a point. I've already used these two, so I can't use those points. I'll use this point, the turning point. And so I substitute my Y value. In this case, it's my gradient, but this is my gradient. This is my gradient when X is negative a third. So A, when X is negative a third, sorry, negative 2/3, then my gradient is a third, negative a third. Okay, so now I simply solve for A. So I solve for A by adding, this is negative a third plus 1 gives me a third. This is negative a third plus a third gives me negative a third. All of this must be equal to negative a third, which means when I solve it, A itself must equal 3. If you simplify it, you'll see A is equal to 3. And so now I get that the formula for my derivative is 3x plus 1 x plus a third. So if I multiply it out, I get x squared plus, this is 1 plus a third, so it's 4/3 x plus a third, and everything must be multiplied with 3. So I get 3x squared plus 4x plus 1. So I'm able to find the formula for my derivative. So I found this whole thing is 3x squared plus 4x plus 1.
Now I can equate it to 0 and we will use a long division.
To do what?
And so that we can find the x-intercept of the cubic graph.
This one?
Yes.
Will you make this one equal to 0?
Yes.
No, what is this?
It's a parabola.
No, what is it compared to the original one? Of the original?
Oh, it's the gradient.
It's the gradient. So when you make it equal to 0, you are finding the turning points for that gradient. You already have those points. It's these 2 points.
So sir, don't you take like the point, the individually, like for example the 3x squared, and let it equal to what you got Yeah, and then equal to the first. Yeah, to the. Like for example, 3x squared equal to 3a.
Yes. So in other words, 3ax squared must be equal to 3x squared.
Yes.
So a is equal to what? 1, thank you. 2bx is equal to 4x. So b is equal to? C is equal to? 1. So far we have that fx is equal to x cubed plus 2x squared plus 1x plus d. We just don't know what d was because this one didn't have a d in it. So, but that's okay because they also gave me this. When I substitute 0, I should get 0. What is this? If x is equal to 0, what am I working out? Y-intercept. What is d? The y-intercept. So d is equal to 0. So my final answer. Point being, guys, is that what I have here, I must work backwards. So in other words, if I know that this is the derivative and I want to know what did I derive, it's called the antiderivative. The antiderivative is what did I have before I had this. If I have 3x squared now, it must mean that I used to have x to the power of 3. Do you understand? If I have 4x now, it must mean that I had before a 2x squared, so that the 2 times the x. So the antiderivative, you'll do it when you do it in varsity. Okay, the antiderivative works like this. If I have, they use it looks like this. This means the antiderivative. The antiderivative is what did I derive to get x to the power of n? Well, it's exactly the opposite. Instead of multiplying the coefficient, like I used to multiply and then subtract. Now I must do the exact opposite. I first add, so in other words, x n plus 1, and then I divide with n plus 1. Do you understand? Where before, I used to multiply first, and then I subtract. Now I must add first, because I'm doing the exact opposite, even in the opposite order. I subtract first. So for example, if I have x to the power of 3, or if I have 3x to the power of 2, I first add 1, x to the power of 3, and then I divide the 3 with 3. So the antiderivative, well, not antiderivative, looks like this. Antiderivative of the inside is just doing the opposite of the derivative.
So what happened to, you see, cx equals 1, so what happened to the x?
Cx didn't equal 1. C equaled 1. Here, we were comparing these things with each other. These things. C was equal to, so in other words, if I tell you that I found the derivative of something, the answer is 4 when I took the derivative. What did I take the derivative of?
I don't understand.
I took the derivative. I'm telling you that my derivative is equal to 4. What was it before I took the derivative?
It was 4x.
It was 4x. Understand? If I tell you my derivative is equal to 6x, what was my original?
It was 12x squared.
You sure?
Yes.
Take the derivative of that.
That's 22. That's 24.
Yeah.
It's okay. It's 3
Yeah,
x squared.
excellent. You get the idea. So if I have the derivative, I must try and think backwards to get the original, the antiderivative. Okay. So, and it's very likely that they will ask questions like that. That was my own question I thought up. But it's not unlike that they can ask questions like that. Okay.